think we were at 1 degree this morning when we came to the mill. A
Mhm.
nice balmy day up here in Madison. So for those of you that are, well, I can't say that. Normally I could say for those of you in warmer climates, but I know that many of you that are in warmer climates this week, it wasn't warmer.
Yeah.
So my name is Scott Johnston. I'm the sales and marketing manager for TimberHP, and just really excited to kick off the meeting here this afternoon. What we have teed up is we're going to show a video that was recently produced by the University of Maine and their fiber incubator lab, if you will. We work hand in hand with them. And when we get into the presentation, both Steve and Jess will talk more detailed about that, but we'll tee it up with about a 3-minute video. And what we like about this video is some of you have been to the mill. Many of you have been here 2-3 years ago. So you'll start to see immediately that there's a lot of changes up here. We are up and running, and you'll see that. The other part that I love about it is for those that have never been to Maine for that matter, let alone Madison, you'll see some cool drone footage of our town and certainly coming into the mill itself. And then you'll also see some images of the mill. And once that's done, I'll officially have both Steve and Jess introduce themselves in terms of their background educationally and what they do here. And then they're going to take us through a presentation of how we take wood chips and make them into our finished goods, which today are TimberBatt and TimberFill. That's on market. We'll certainly get you an update on that. And you'll actually see the manufacturing of those two products through a PowerPoint presentation. And then when we spin off that, we'll make sure we answer any questions that are out there. And then towards the end, what we want to make sure that we do is provide you with an update on TimberBoard. A number of you are here wanting to know about that. I know there's a lot of folks from the architectural and design community. And we also want to make sure that we educate you in terms of where to go and procure the products throughout New England, the Mid-Atlantic, and other parts of the United States. And it just so happens that today, we have a sales and marketing meeting on site. So towards the end, we'll have some of the folks from the sales team come in and we'll introduce you to them. And we'll also have a slide at the very end that'll have their picture and the territory they cover with their email address as well as their phone number. So thank you all for jumping on today. And again, our esteemed hosts today, kicking it off, will be Steve and Jess, and we'll pick it up on the backside and get you more details on the two of them. Thank you. Oh, I guess this is me.
Yeah, we'll kick it right back to you, Scott.
Don't get off this easy. So it's interesting. You never know who's been on the meetings before. And I know there's a lot of folks that join every month, and we appreciate that. So for you, this might be redundant. But for those of you that this is the first time learning about TimberHP, this slide does a really nice job about what we're up to here at the mill. So TimberHP, 90 to 95% of our raw material is wood chips, which is obviously from timber, from the forest. And what's really unique about this is the fact that we're leveraging technology from Europe, 20-25 years over in Europe. So in essence, that's our white paper. It's been proven, and there's upward of 8 manufacturing firms that are over in Europe. It's a billion-dollar industry and growing. And they only do about 26% wood frame construction in that European market. Excuse me. Here in the United States, we're upwards of 70 plus. So it's an interesting technology that we're bringing over here to the United States. And we're the first dry wood fiber insulation manufacturing facility to come online here in North America. So we're really, really excited to do that, because that way you can get rid of that need to import. That's very expensive, and it kind of goes against the grain of what we're trying to achieve here with low embodied carbon to make products. So coming online here in Madison is wonderful because it really helps offset that, and it also makes it more economical. So we take that wood fiber and we're really storing that in a finished good. We are providing wood fiber insulation, which is a blown-in insulation, as an alternative for the attic space, as well as dense packing. And then we also produce a TimberBatt for wall cavities, rafters, floors, etc. Both of those products are online today. We also will be making a TimberBoard, and Steve will get you up to speed on where we're at with that production process in terms of bringing in the equipment. We talk about high performance. You're all being challenged to help with regards to maintaining cooling and heating in the home and trying to reduce fossil fuel consumption to do that. And oftentimes you're forced by code to use a high R value, which is great, and that addresses the operational carbon. But the concern is sometimes we might short circuit our design in a wall cavity, and we might have a situation where we're trapping moisture in that wall cavity because perhaps on the exterior we might be using a continuous insulation product that has a zero perm. So if it's not designed properly, we've got to make sure it's designing to the interior. And we can manage to that, design to that. Code gives us the ideas in terms of how to perform that. But by introducing wood fiber insulation for the cavity wall, and inevitably when we come online with the TimberBoard, it actually allows for an open assembly to allow to take moisture and move it through that assembly, so it helps to reduce any liabilities there. Highly recyclable. I mean, you're working with wood. We love it. When we bring our products up online, when we're producing TimberBatt, if we've got our first run and it's not to where we want it, we can actually put it back, reintroduce it, and put it right back into play. If you're blowing TimberFill out on a job site and it spills into the garden, we're not worried about that because it's not a concern because it's all natural material. And then that speaks also to the non-toxic materials. You know, we want to make sure that we perform to the R value. We want to make sure that we perform for fire codes and things such as that are critical for you to actually entertain specifying us. But we want to make sure that we're doing it with non-toxic materials. With the fill in the bat, which is on market now, that's an E84 flame spread, which is a class A, and that's because of borate that we use. It's a liquid borate process, which you'll see in the presentation. So we are up and running with those two products. I think there's one more slide.
Yep, we're kicking right into the.
And we are going to show you, this is you can stay warm in your office right now, and you can have a tour of the facility. Thanks, Jess.
A wood chip is a fascinating thing. And when I think about what the University of Maine has done with some of their biofuels efforts, and now the turning a wood chip into insulation, what is the next innovation that is going to lead to?
We have this future that we envision, not just in Maine, but everywhere, of sustainable products in every sector of the economy.
When we started this company, we were focused on creating the next generation of sustainable building products that utilizes our resources, our natural resources, and in these communities where we've traditionally manufactured, in this case, paper, but now wood fiber insulation.
When we found this mill, it was about the people who had worked here before and what their knowledge of not just this building, but 24/7 wood products manufacturing and all of the value that they brought.
It's really about finding the partnership, and Humane Advanced Structures and Composites are the partner for us to be able to take what we can do well, which is the manufacture, and to bring in what they do so well, which is the building science and the science behind wood, and really work together to ensure that we have a robust opportunity with these products that are durable and are going to perform well, and quite honestly, are going to result in the next generation of building systems.
To be part of the team that brings a manufacturing site back to life, it means a lot.
All of these are Maine folks who want to see some growth opportunity, that change. And it's really about all these diverse people coming together.
With research and development, it's a lot of crazy ideas, and that results in a lot of crazy problem solving to things you haven't seen before. What the engineering, technology, and humane programs do really well is expose you to as many things as possible. That way, when you get into the industry, I know where to find the answer, and I know what questions to ask that will help me arrive at a solution.
You know, for me, it's not about what any one of us has done, but it's what we've done together. It's about the Maine people doing something that is actually galvanizing and results in positive change.
Well, hey everyone, thanks for joining us today. My name is Steve Thiebert. I am the plant manager here at TimberHP. Very happy to see that video from the University of Maine. I was an engineering grad from the University of Maine a long time ago. What you're looking at here is a picture of the TimberHP mill. This used to be the UPM paper mill in Madison, Maine. And we have embarked on a $150 million or so project to install these 3 production lines to make the 3 products that Scott talked about, and some of which you can see behind us here. It's been an incredible process. It's been exciting and challenging from an equipment and a process standpoint, but the real thrill of this has been building a team and working with a team to start this place up, to make a new product that's never been made here in North America, work with our sales and marketing folks to improve that product as we've brought it into the market. And it's just been a tremendous process. As we go through the presentation today, if you have any questions, please get them in the chat, and Alex will work to feed us those questions if it's pertinent to the topic, or if it's not, then he'll save them to the end and we'll try to answer those questions at the end. So this next slide really talks about what's happened with the timber industry, the forest industry in Maine. I mentioned that I graduated from the University of Maine a long time ago. Well, in 1990, when I got out of school from studying pulp and paper, there were, I believe, 19 mills in the state that were working with the forestry industry to harvest these forests and working with the sawmills to take their residuals and process those chips. There are 4 mills left running in the state right now. And this mill here was an important part of my life, but there wasn't a room for the product anymore. This is really the only mill in the state that has been brought back to life, and we're doing it making a forestry product. And the main raw material is chips. And we're able to take those residuals from the sawmills and make them into a very much a value-added product. And Jess is going to talk about what we do with those chips.
Yeah. So hey everybody, I'm Jessica Vino. I'm the operations manager here at TimberHP, and like Steve, I was lucky to work at 3 other mills in Maine, paper mills on 3 different rivers in Maine. Yeah, I started on the Penobscot working for Georgia Pacific, headed out west to the Androscoggin, working at the Rumford Mill, and now landed here on the Kennebec at the Madison Mill with TimberHP. So what I think is really amazing, and you heard me talk about it in the UMaine video, is Maine has a history of manufacturing for hundreds of years, and we've used our natural resources for a long time. And through many small towns in Maine, along rivers in Maine, you'll hear that was the old dowel mill, or that was the old stick mill, right? That was the old paper mill.
Yeah.
And, you know, we have a heritage here in this state of using our raw material and turning it into something value added. So the photo that you see in the slide presentation, we are sandwiched on 11 acres in between the Kennebec River and Main Street. So we have a real small facility. We actually have a chip tent that covers our raw material, our wood chips and residual chips that come in. You can see in the lower photo, a live floor trailer dropping off wood into our wood yard. Steve mentioned, I think, the residual chips. That's a byproduct from the lumber industry. So we're actually taking a waste stream from another manufacturing process and using that to make our final product. People have asked me a lot, well, what species do you use and why? First of all, we use softwood chips instead of hardwood, just from their base components. The softwood fibers are about twice as long as hardwood fibers, so that gives us more flexibility and strength. And we've really learned a lot about species along the way. When you work with a natural raw material, it changes in the winter, in the summer, if it's wet, if it's rained, where the wood was harvested, when it was harvested, how long it sat. So we are working with a natural raw material, and you really have to like read the raw material, see what it's giving you that day, and make adjustments in your process as necessary. But we run a mixture of spruce, fir, and pine. And it looks like Alex has popped on maybe with a question.
Yeah, absolutely. Hi guys, Alex Donnelly, inside sales for TimberHP. Their question in the chat from Jonathan Petrie. Is there an attempt to source wood chips from small scale mills, or will there be sufficient product available from existing mills for the foreseeable future?
We have a pretty diverse wood sourcing strategy.
Yeah, we've got a couple key facilities that we work with now from arrangements that were made early on in getting the bond financing for this facility. So we're somewhat locked into those now, but over time, I do believe we're going to be branching to other facilities. The key for us is getting a consistent supply of chips. But whether the manufacturer is large or small, I don't think really will matter to us. We'll cross those bridges as time goes on. We've got a lot of things in play right now, so having a limited number of suppliers just really helps us keep things consistent at this point in time.
Mm-hmm. Thanks for the question. Please pop the questions in and we'll try to answer them live if we can. So this is a video of our chip conveyor. The chips have to be brought into the wood yard where they're put into a hopper and then they're run through a set of screens. So we remove the very small particles and remove the very large particles. Then the chips go up this quite steep, actually, chip conveyor to the top of the roof where our chip hopper is that sits right over our digester. This fiber line is going to supply wood for all three of our products. So the wood yard is common to all three products. It's once we get inside that we have a choice if we want to send them to fiber line number 1 or fiber line number 2. We'll show you that coming up.
So now we're inside the mill and we're going to start to process these chips that we've blended and screened, and now they've entered the building. And the left shot, you can see we're pointing up at this vessel called a pre-steaming bin. And so before we refine our chips, we've got to soften them up. And we do that with some steam. And that pre-steaming bin is just taking steam at atmospheric pressure and pumping steam into that vat to just start to get those chips warmed up and softened up. And then we're going to take them to the screen on the right. You're looking at a digester, and this is the top of the digester. For any of you that are familiar with the paper industry and you hear about digester, you're thinking about, okay, they add a bunch of chemicals to dissolve the chips. That is not what we're doing here. This digester is simply a pressure vessel where we use about 100 PSI steam to help soften those chips further before we refine them. And the reason we need to soften them is that helps the refiner liberate the fibers wholly instead of breaking them into really, really fine dust. So the key of this, one of the key elements of this process is to be able to do that on a continuous basis. So as you can imagine, you've got this basically pressure in the room that's in this tank, the pre-steaming bin, and we've got to get it into this digester at 100 PSI. And to do that on a continuous basis, these chips come in and go through what's called a plug screw feeder. And this screw compresses the chips in like a cone, and it forces them to make a plug. And this is a plug that would separate the high pressure side from the low pressure side, and that screw runs continuously, and this plug keeps the pressure different. Yeah. That allows us to feed these chips into the digester on a continuous basis. Do you want to talk about the...
Yeah, sorry. The
No,
plug
that's
screw feeder
fine.
is so exciting.
Yeah.
I didn't know if there'd be any questions on that, Alex, but we'll move on.
We do have one question in the chat.
Okay.
Not about the plug screw.
Oh,
Sorry. The actual question is, do you burn chips as fuel in your boiler system as well, or do you use bunker C or some other fuel source?
Our fuel source is natural gas. So one of the beauties of this site is several years before the paper mill shut down, we benefited from a natural gas pipeline coming into the area. So we use natural gas for our boiler to generate the steam, for our dryer, for our oven on our batt line, for basically for all of our heating sources, we use natural gas.
Great question, though. So if you can picture, we had just looked at the top of the digester. So now we've moved one level down in the mill. We're actually looking at the bottom of the digester. So at this point in the process, the chips have sat in that 100 PSI, approximately 330 degrees Fahrenheit. They've sat there for 5 minutes, maybe a little longer. So now they're really soft and they're ready to go into the refiner. When I give tours here, we kind of joke, the refiner does not look like much from the outside, but it's really the whole heart of the mill and what we're doing. So I brought for you very heavy plate. So what I'm showing you is one segment out of 12. There would be 12 of these segments to form a complete circle. And then there would be a duplicate set of 12. Essentially, it's a modern day grinding stone. And when I was talking about Maine's history in the past, you know, I always love to tell the story about going to Lubeck and going to raise mustard and seeing the grinding stones making the mustard. It's the same idea. We have one stationary plate. We feed the wood in between the two plates, and the other plate is turning at 1800 RPM. So essentially, those softened wood chips are getting put that down. There we go. Those softened wood chips are seeing so much energy. We call it specific energy that is shearing the chip open, and it's liberating all of the fibers. So the reason I said this is the heart of the mill is because this piece of equipment is how we adjust our fiber size. Do we want the fibers a little longer and shaggier? Do you want them a little finer and smaller? So that's how we do that. The other thing that differentiates our process, I hope you can see my pointer, but out of the refiner, we enter what is called a blow line. Our fire retardant, as Scott mentioned, is a borate-based fire retardant. It comes from Turkey in super sacks, and we make it down in a hot water solution, and you can see probably most clearly, you can see these two injection nozzles. We inject the borate as a wet solution into 50% moisture fiber. So it gets really well mixed, really well coated, and we get a really efficient application of the fire retardant. Let's see, I'd love to show you this video. When we first start up at the beginning of a run, so the first chips that go into the refiner, you start with the plates wider than they need to be, and then you slowly bring them together. And as you bring them together, the fibers are going to get finer and finer until you hit your quality specification, and then we send them on for further processing. Looks like we have a question though, Alex.
Yeah, a couple of them. We'll go with the one that's really pertinent right now, and then we'll fall back on the others. But what determines the optimal fiber size?
So I have a great story about this, or I think it's great. When Steve and I both worked in a paper mill, the specifications are really rigid. There's all of these tests that you can result in number, freeness test, for example, and how much do you refine your fiber? And so I came here, and one of the first questions I asked to the commissioning engineers was, well, what test do I use to determine what's the proper fiber size? And they said, you'll just know. I said, well, that's a little vague.
Yeah.
So what's really funny though, and all of our operators will tell you this, when you look at this fiber every single day and hold it in your hands every single day, you can tell. We do have a quantitative metric, and we put the fiber through sieves, and we have a mathematical breakdown of what the fiber size is. But it's really amazing at these sizes. It's really easy to perceive by your eye. And so you can kind of tune in, Alex, to what is the proper fiber size. So
perfect. Another follow-up on this, similarly related. What energy content do we use of natural gas? Essentially, so the question was, what is the energy content from natural gas in some quantity of product? But I think they're just trying to really get a gauge on how much natural gas we use in our production.
yeah, I know it's.
Yeah.
I don't know it in a percentage, but I can compare it to like other processes. I don't know if it surprised anyone when I said, you know, the digester is only at 330 degrees. That's using steam. That's that's not very hot. When you think about, you know, melting slag for rock wool, for example.
Yeah, exactly.
So, the other thing is when we get the chips out of the refiner, we have a slide coming up on our drying system. We're taking the moisture from 50% down to roughly 10. So I don't know, I guess it's hard to say in a percentage, but comparing to other products, it's a very low energy intensive process.
Yeah, and it's a little tough to dial in because you've got, like, this one common line is feeding both our loose fill and our batt line. And our batt line has another unit operation that uses some gas. So how do you break down the gas consumption that's creating the steam for this part of the process, and then somehow prorating the gas to another part of the process? So we don't have any, you know, MMBTUs per pallet.
What did you say, Scott, off the top of your head?
So 2,700 degrees Fahrenheit on the other process versus 350. So that's a significant reduction in
Yeah.
consumption of.
I think to this person's question, because we're a startup, we don't have all the meters in place to do a full life cycle analysis, but it's one of our goals. And like Scott sharing that temperature for
Mineral wool.
For mineral wool
Yep,
slag.
2,700 degrees.
Yeah, it kind of just gives you a feel for the difference. Great question. I'm going to show you this video. This is our startup cyclone. This was during commissioning, so we were all really excited about it. That's why there's danger tape there. But this is some of the first fibers we've made. I think this one was me too. So if you can picture in your mind that fiber you just saw blowing out of the startup cyclone, we have a diverter valve. As soon as we're ready, the fiber looks good, we switch this valve over to our flash tube dryer. And what is a flash tube dryer? The photo on the left that shows the burn chamber is a photo I tried to grab. We've got a little viewing window of our natural gas burner. So that's what you're looking at, the flame there. So it's natural gas fired with a huge fan to heat up the air and then move the air very, very quickly. So the fiber gets injected into this duct, the wet fiber. Within 4 seconds, it's traveled the length of the duct and has come out of the separation unit, which is the high efficiency cyclone. And the moisture change during that process is from 50% moisture down to about 10 to 11. I think I've got a video here, but so the job of the cyclone is really just a separation device. So you're going to see the warm, moist air leaving all of that moisture that you've driven off from the fiber is exiting the cyclone out the stack on the top. And then your dry fiber is going to swirl around and separate out of the cyclone and will be ready for processing. I think commonly Steve and I were talking while we were looking at you know, people in the community might call this your smokestack. It's not smoke. You're seeing the moisture and the vapor the water that's being driven off of the raw material as it dries.
So now we've made our fiber, we've processed our chips, we've made our fiber, we've added our borate, we've dried it in the flash tube dryer, and now it's time to take that fiber and run it through our 2 production lines. The first of which is our loose fill line. It was the first to start up. This little video sort of shows the processing of this, but what we're basically doing is compressing and packaging that raw fiber that we just made so that it can then be sent to our customers and blown into attics and wall cavities. So this first part of the process is just a compression chamber. We feed the fiber into this chamber using an auger, and there's a ram that comes down, that black device in the middle compresses that fiber, and then it's gonna leave there and it's gonna go across the scale that where it says M16. So we weigh each bundle and then we recompress it and send it. We got the little squish there. We recompress it and finish our packaging part of the process. After this, we check the bundle for size. We can't have bundles that are too tall or it messes up our palletizing. And also, since this video was taken, is we have an inline moisture meter and we check the moisture on each bundle and have specs set up so that we can kick bundles off the line if they aren't the right moisture content. So that's really the basics of loose fill. It sounds very basic, but that's been a very tricky line for us to work with and get the product right. And there's been a lot of iterative process feedback through our sales team from our customers. It's taken a lot of work to get things right with the loose fill process. So we're going to move over to the batt line process. There's Scott. Take 2 clicks to move over to the batt line. So now with the batt line, it's a more complicated process, and it starts with a additional additive. So I'm sure you've handled batt insulation. It's like a loose matrix, but there's some strength to it. You can sort of peel it apart. Well, you need to bond those wood fibers together in that matrix. And to do that, we use a material called bicomponent fiber. And I've got it here. It looks like cotton. I think Jess is going to lay that right there.
There you
But
go.
this bicomponent fiber gets mixed with the same wood fiber that we would use for loose fill comes over to the batt line. We mix it with this bicomponent fiber. And these fibers are very, very fine. It looks like cotton. It's probably hard to tell on the screen, but it's very, very fine, very, very soft. These are 6 millimeters long. So you're only talking 1/4 of an inch long, and they're very, very fine, but they're actually made of 2 components, thus the name bicomponent fiber. The 2 components are a core and a sheath. And the core has a higher melting point than the sheath. And this is really what's key to this whole batt process. We're gonna mix the bicomponent fiber with the wood fiber. The video on the right is showing mix those together. We're gonna now form this into a mat of fibers that is 8 feet wide in our forming section of the line. And that sets us up to head into our oven. So you can see, there's the fibers filing into the former.
Yep, getting a little pre-compression.
So now here on the left is the oven. And the purpose of the oven is twofold. There's a top belt that can move, and that sets the thickness of our material. So like what we were producing today, like what's here on the table, we're producing for 2x4 wall cavities. So we've got a 3.5 inch batt that we're manufacturing, and those belts will come together and take that mat off the former and come down to 3.5 inches to set that thickness. That's one of the key functions of the oven. But the other key function of the oven is to get the temperature up inside this so that we melt the sheath of the bicomponent fiber, but not the core. And in doing that, the sheath is made of polyethylene. And as you can imagine, once you heat that polyethylene up, it gets tacky, it gets soft, it bonds these wood fibers together in this matrix. And by not melting the core, it still maintains its integrity. So that core helps with the strength of holding the individual fibers together inside this batt structure.
We're gonna find our mouse here. There we go.
All right.
So the process steps, Steve just talked about the oven. When the batt comes out of the oven, it's very warm, very, very, very soft. So it needs to go through essentially like a curing step where it cools down, and that polyester core can kind of cool and set and be ready for further processing. So the video I'm going to show you here, the reason that edge of the bat looks quite irregular is it's a start of a run. So it's a bit irregular and it's coming out of the cooling section where we're trying to set it. Let's see if I can pause this video right there. So these ducts that you see, we have rip saws that cut the product to width. So if you want a wood stud spacing, we can you can order that. If you need steel stud spacing, we adjust the saws so you can order that. And these ducts pull all of the sawdust from cutting away. Once the product is cut to width, we have 2 vector saws that are going to cut to length, but I think I've got a better video of that. I'm going to pause here just to show you guys kind of the expanse of our room. Paper machines are very large and the operating floor is very long. So one of the great things about this mill, it had plenty of space for all the equipment that we were going to need. So the black conveyor belt that you see is going to take those cut bats that are cut to dimension, stack them up, put them through our heat shrink wrap machine into a bundle. Those bundles are palletized and then hood wrapped and sent to our warehouse for storage. This video I'm showing on the right is our vector saws. And as the product is moving, the vector saws, you can see they're pitched at an angle because they have to travel with the bat as the bat's coming down the line. So as I said, we do both wood stud and steel stud dimensions, so 47 and 48 inches long. The product thicknesses that we make on this line currently are from 3 inches all the way up to 7 1/4. And like Steve was talking about the thermal bonding fiber, every single thickness we make has a unique recipe. So we try to strike the right balance between strength and flexibility and compressibility depending on the thickness of the product.
So we've talked about our first 2 production lines, which are up and operating and providing a great product out into the market. The third one, as Scott mentioned, is our board line. And this is a picture looking down the room at the board line, which has similar unit operations to the bat line, but it'll use a like Gorilla Glue type adhesive to make a firm board versus the flexible bat. This production line was in operation in Germany for approximately 8 years. Our co-founders bought this line before they even had a place to put it. So we're happy that they found the Madison mill and it's been a good place to put it. Over the last couple of years, we have completely reassembled the line with a lot of help and guidance from the original equipment manufacturer, a company called Diefenbacher. They've been incredibly helpful and we've got it 95 to 98% complete. We were well on our way, but had to put the brakes on this project in early 2024 for financial reasons. We're currently working on our Series B fundraise, and a key part of that fundraise is to complete the construction and conduct the commissioning and get this line started up. And we're very close to having that fundraising done, which should put us on track to do our commissioning process through the summer and with the target of having a board product in the fall. So with that, I think we're going to hand it back over to Scott and his team.
Sure, thank you, Steve and Chess. That's outstanding. I hope those of you that may have attended these calls in the past, I can't see how you wouldn't have gleaned something new. That level of deep dive into the production is fantastic. So what I want to do is just remind folks of the 3 products or the 2 products that we're on market with. And then what we'll do is we're going to shift into, where to procure the material. And I know there's people from all over the place. Primarily right now, today, our target market, because we're located in Madison, Maine, so we have to think about transportation. But what we would call our ideal market would be all of New England, New York, Mid-Atlantic. We are also out into Ohio and Indiana. That kind of takes you a little bit beyond the 500-mile radius. We are partnered with Cameron Ashley Building Products, who have 60 locations across the United States. So for those of you that are away from the geography that I mentioned, there is a pathway for us to get you product. It's a bit more expensive because of the transportation. And Alex Donnelly, who's been feverishly responding to your various questions, is here in the room today, and he works magic for those situations. But what's critical is as we come out into the market, is we ideally want to work in our backyard, working with architects, designers, developers, builders, remodelers, our channel, so that we can go out and do the due diligence in the field, creating the education and creating the interest. And we'll continue to expand beyond that. The two products, just to remind everybody that we are on market with, is TimberFill. And Steve, I really appreciate your candor during the presentation. When you come out and do this, it's new. So you learn through doing. And many of you on the call appreciate your feedback, because we've really come a long way, and we'll continue to improve that. We really want to make sure that we're providing a phenomenal product that's easy to work with and use. And kudos to Matt Damon. I don't know if he's snuck in the room yet, and Jason Todd, who's not in the room today, but and the marketing team, because as we've learned, we've created a lot of great resources for installers and or architects. So don't forget to hit our website, because what we do, where we didn't have it a year or so ago, is we will coach you in terms of what the ideal equipment would be to use for the attic application or for Dens pack and things of that nature. But fully online, TimberBatt as well. And that we're almost about a year now into the production of TimberBatt. So super excited about that. That cubes out a truck pretty quickly. So I think you can appreciate why we want to work in our backyard. However, the appetite for this product is such that we're shipping out to the West Coast. We did a really nice 55 and older community with 4 trucks going out to Austin, Texas. We won't say no to an order. We want to make sure that we're completely on a large, commercial jobs and things of that nature. Reach out to us. Let us help you with that, whether it's procurement, costing, or coaching. As I mentioned, with having Matt Damon, who comes from the industry on the cellulose business, owned his own business. And, we don't want you to go it alone or have your installer go it alone. There are projects where we'd like to get involved and help you out. So for those folks that are here in New England and New York, like I said at the beginning of the presentation, we happen to be doing our sales and marketing meeting here at the mill, and we're not up here that often. And I wanted to have a chance for Bill and Addie and Paige to introduce themselves, give a little bit of their background before they came to work here at TimberHP, and then reiterate the markets that they serve. So, Bill, you're the local boy.
I'm Bill Ryan, Timber Territory Sales Manager here for Maine and New Hampshire. I've been in the building materials industry for over a decade, and previously with Anderson Windows. So I find myself all across Maine and New Hampshire, a little bit on the edge of Vermont, depending on where the project leads us, but happy to support installs, specification inquiries, really kind of anything from, the start through to procurement and install. So please don't hesitate to shoot me an email or ask any questions. I know my phone number is on the website as well. So fire away.
Hi, and I'm Addie Atkins. I cover Massachusetts and Vermont for the company. I've been in the building materials world for a while now, first time into installation, but I've been on the decking, the siding, trim side of things. So feel free to reach out if we can help with anything, whether it's, getting a job priced out, connecting with installers in your market, where to buy. Good to see you.
We don't have his pretty photo. Matt Damon.
I'm Matt Damon. I'm the field education specialist, and I work with installers in the field to help get products in their hands, get their settings dialed in on their machines, right? Hose choices. I do a lot of remote and in-person field support, both with the bat and in the fill and the board when we get it out. So if any installers or homeowners kind of in the field need questions answered, just give me a shout. So all my information's on the website.
That's awesome. You look at this team that's here, everybody serves a purpose and it's so important. I mean, having Jess and Steve here in this presentation and walk you through the manufacturing and their history with the University of Maine and the paper business, I gotta tell you, that was an outstanding presentation and thank you for that. And, the resources that we have online are great, but call us, we wanna make sure that we can, whether it's just a quick phone call or a quick email, or it might be something where we're gonna work with you on some budgeting work, design work, or need to get out at the job site. We're not clairvoyant. So when there's something there where you need that extra help, we wanna be there for you. That pre-construction piece for multifamily or a large residential project, we wanna make sure that we're there for you. However, everything's 24/7. So our website, really for a fairly young company, and I've worked for a number of companies, Anderson and Huber. I'm super excited what Claire and Edith on the marketing team have done and many others. It's a pretty easy site to navigate. And even though we're a scrappy young startup with limited funding, the resources that are out there are pretty amazing. So take advantage to get out there. So if it's something where you're looking to specify us, we have our 3-part specification out there. And for those architects and designers that don't want us to get in touch with you because you want to remain, behind the scenes, go hit RCAT. You can go out there and have anonymity to that. But in addition, on our website, lots of great PDF documents that speak to cut sections, cutting tools, for example, with BAT. As I mentioned a little bit earlier, we have the great resources, and Matt was helpful in putting some of this together. What's the right machine that I should be using for the right application? There's an awful lot out there, and videos. We know that some people are not going to read through a documentation, and so we have a lot of video content that's out there. Paige, I know she had a family issue, but Paige Malloy is our New York and Connecticut representative, and her contact information will be on the last slide. Her background is with the Henry Company, and she also worked with Rockwell. So a lot of folks, all of us, have worked with other corporations in the building materials sector. I am not gonna not introduce Alex Donnelly. He's been hiding behind this timber. This is the guy.
Hello, everybody.
So if we do our job right in manufacturing and sales, and we get the PO, and by the way, we love your POs and specifications. Alex and Gianna, who's not here today, do an amazing job of working with that channel that we spoke about. Cameron Ashley, LBM Advantage, and a whole host of retailers that are buying our product directly. So, Alex, any other little tips and tricks for you in terms of your world and getting material to projects?
Tips and tricks, getting material to projects. PO is a great place to start. Follow that up with just to reach out to info@timberhp.com or sales@timberhp.com. Give us a ring on our 855 phone number, or follow us up on all the social things that I just put in the chat. So if you got any questions, we're happy to help.
And thank you for that, Alex. I appreciate it. The other thing that we'll let you know, many of you, and we really love to work with you, we have done the AIA CEU that's available, the Wood Fiber 101. We're getting closer to getting out to the market with our second AIA CEU, which is huge, right? And that's fire and sound. Because we know a lot of the places that we need to start, both residentially and multifamily, light commercial, is we need to make sure that we help communicate as to where we fit, right? So we hope to have that launched. We also are really big believers in associations, whether that's the home builders, remodelers, AIA, Passive House, Nessie, and I'm sure I'm missing some. We try to be as engaged as possible, and we look forward to seeing a host of you at these various shows. And unless there's any other questions, do you have any other key questions that we want to get after?
Nothing major right now. No.
We just want to thank you so much for spending a good portion of an hour. And being that we are ending early, I'm sure you have other things to do. Thank you so much, and thanks for considering TimberHP.
Thank you.
Thank you.